Good morning, everyone. My name is Kai Chen, and this morning we will brief talk on EMR, introduction to a new digital voice mode for amateur radio. The objectives. The objective of the presentation is really not to make anyone a EMR expert.
What is DMR? Remember, what does it stand for?
Okay, well, if you let me...
Okay.
Okay, it's not meant to make anyone an expert, but just give folks a just basic idea of what EMR is and what it offers to hams and what it can do to hams and comparatively how does it compare to other analog and also to other digital modes. So if at the end of the presentation all you walk away from this presentation is what DMR stands for, I'd be very happy. Okay. So what DMR stands for is Digital Mobile Radio. Digital Mobile Radio is a ETSI published global standard. ETSI is the European Telecom Standards Institute. It's a published global standard. You can go on their website, you can download it, you can read it. It's got the full standards there. There's over a dozen manufacturers of radios. These are the brands that offer today, but there are many others that are appearing. In fact, the last 2 years, as we speak, well, now it's probably out to two dozen manufacturers. So it offers a lot of choice, right? And with a lot of choice, you have economies of scale. So not one vendor controls the market, and you get a lot of choice. What DMR features is a superior voice quality versus older digital modes. I'll also show how it yields longer battery life, okay. And also supports a concept to digital radio called talk groups. Okay. Talk groups is used very extensively in the commercial market, and we can see how that applies to radio amateurs. What DMR also supports is data applications. What kind of data applications? Whether you are sending texting or you're embedding GPS information into your radio transmission. Digital mode radio is also has that feature embedded into the standard. What supports DMR is a commercial association called the DMR Association. DMR Association's objective is to have manufacturers, have software developers, have public and commercial members together so that they can make the standard better. Also to promote interoperability, because just because it's a very detailed standard, every manufacturer's interpretation is different, and when you have different manufacturers' interpretation, there may be differences. So the best way to do is to have everybody interoperate, just like on your cell phone. There's a 3G standard, there's a 4G standard, but in the background, the different manufacturers manufacturing the equipment are always getting together to try and make sure that their equipment all operates with each other and conforms to the standard. Next one is intellectual property licensing. One of the founding members of the DMR Association, also the major contributor to the DMR standard, is Motorola. In exchange for Motorola contributing their intellectual property, their patents, to the DMR standard to allow for wider use. Motorola has agreed to license their intellectual property or their patents to all the member licensees for a reasonable fee. The reasonable fee meaning that if a licensee finds the terms are onerous or unreasonable, they can actually file a grievance with the ETSI, and the ETSI will determine whether the terms are reasonable. Now, what Motorola has said is that their licensing is dependent on how many units are sold, what type of equipment is being manufactured, whether it's a N-unit handheld, N-unit mobile, or repeater. So far, with the number of manufacturers that signed on to be licensees, you see, it's the fees are not unreasonable, and considering the cost of some of the radios being sold today, intellectual property is not an issue, because if a manufacturer can sell a DMR handheld for less than $200, sometimes for much less than $200, it's really not the patent that stands in the way of affordability. Also, another thing to take away from here is that notice that this is just a list of licensees. There's no list of top tier, first tier, second tier, third tier. So if one of these manufacturers makes a radio, it really doesn't qualify as being a knockoff, because a knockoff is something that's presumably done shady or illegal. These folks have all stepped up and have paid the fee, so their radio is just as legal and as all the major manufacturers. All right, DMR standards. There are what's called 3 tiers in the DMR, and the amateur world actually mostly works in the tier 2. Tier 2 being the conventional, but I'll briefly describe what tier 1 and tier 3 are. Tier 1 is what's called the unlicensed. In Europe, they have what's called the PMR 446, which is like our FRS in the United States. Okay. So their tier 1 is essentially DMR for FRS use. It's just a digital implementation of the protocol and has nothing special. Right. DMR tier 2 is what's most used in the commercial world, is what's called tier 2 conventional. Tier 2 conventional is used for licensed conventional radio systems, mobiles and hand portables, operating from 30 to 1,000 megahertz. I will repeat this many times throughout the presentation. 30 to 1,000 megahertz. So this is not just for radio.
Is there a test at the end of it?
No. The only test is if everyone walks away knowing what DMR is, I'm very happy. Okay. All right, from 30 to 1,000 megahertz.
Are the radios FCC subject?
All the radios that are here are all FCC Type 90 accepted, which means that they are cleared for use, cleared for commercial use. Okay. And as folks may be aware, the Type 90 testing criteria is a lot stricter than the Part 97 or Part 15 criteria. Basically, Part 97 really has no criteria. They're relying on the operator and the experimenters to make sure that they're not radiating off-band. But even Part 15, Part 90 is a lot stricter than Part 15. I'm sorry? The hazmat, that's not FCC, that's another authority. There are some radios that are manufactured for hazardous environments, but they're not in these. All right, so Tier 2 conventional has what? targeted users that need spectral efficiency, advanced voice features, and integrated IP data services and license bands. So I'm going to go into a little more detail with that. And DMR Tier 3 is not used for amateurs, and that's the trunk radio system. That allows for radio trunking and supports switching and other services that trunking needs. So Tier 2, the conventional, licensed conventional use, which include amateurs, operating from 30 to 1,000. The radios that you see here in front of you, some are VHF, some are UHF. There are ones that are available on the market that you can buy for 800 and 900. But if you see, DMR is designed for 30 to 1,000. What that means today is that today nobody makes it for 6 meter yet. Nobody makes it for 10 meter yet. But if there's an application, there's going to be a manufacturer that's going to be entering the market if they see there's a need. Okay. So again, DMR Tier 2 is targeted at users who need in license band spectral efficiency, advanced voice features, and integrated IP. What I have here is the ETSI website that anyone can log on to on their web browser. They can download the DMR spec. Many hundreds of pages. Makes for interesting reading if you can't get to sleep. And it's very detailed down to the fact that with the 4 or 5 volumes, you can build radio. This is not like some other standards where there's a 10-page pamphlet on what the basic waveforms look like, what the basic structure looks like, and ends up only one manufacturer makes it. Okay? This is something that, get the book, you can technically make your own radio. Okay. So what are the DMR main characteristics? DMR main characteristics, one being that it's a 12.5 kilohertz channel. And it's not just a 12.5 kilohertz channel, there's others. In that 12.5 kilohertz channel, you can push 9,600 bits per second gross bit rate. What that means is that you can push 9,600 bits per second without any kind of error checking or error correction. What's used in DMR voice, you can put error checking, error correction, so that your yield is about half as much. But that yield is very robust, meaning that it can recover from single bit or two bit drops. It can recover. It can recover sync if it starts dropping entire packets, meaning that if you're in the middle of a transmission and you lose sync, as soon as the next packet is successfully read, you get your sync back. Okay, that's very, very important if you're doing any type of reliable transmission. Also features 4 FSK modulation, constant envelope, and within this 12 kilohertz channel, you have a 2-slot TDMA channel. What does 2-slot TDMA mean? 2-slot TDMA mean is that in this one 12.5 kilohertz channel, you can have 2 simultaneous independent QSOs. 2 simultaneous independent QSOs on one 12.5 kilohertz channel. And this is compared with analog, what amateurs have in analog today, which is a 25 kilohertz channel with 1 voice channel.
Now, to me, with depending on what project we get contracted.
Channel's still up there.
I'm sorry?
Channel's not 25 kilohertz, it's less than.
Well, but you got guard bands.
Right, but the actual channel is.
Right.
Yeah. About like this.
Well, the point here is that the design of DMR allows want to put another repeater 12.5 kilohertz away, and there would be no interference. As long as you have your transmitting equipment properly isolated, there will be no interference. That's the design of the CMR.
Okay.
Yes.
I just recently, a couple of years ago, went to digital TV,
Okay.
rather than analog.
Mhm.
And of course, with digital TV, we use the wider bandwidth than an analog, or about the same bandwidth. But ultimately, what's happened is the channel bandwidth has actually become less efficient, if you will. So we can transmit as long distance. I mean, analog, we can get snowy pictures from Long Island.
Sure.
Now you have to put a little more gain up to get the clean pictures, no snow, but when it drops out, it's done. Now, with this kind of stuff, I haven't played with this at all, but I assume that given the channel capability here, you can get almost as good characteristics as you can with analog FM. In other words, when you start getting noisy, this will not drop out. You'll just get, you'll lose packets that affect sound quickly, you're not going to lose it, are you?
I have a slide for that.
Okay, go on.
One more question. You said forward and reverse transmissions. Now, that's like, within each of those two channels, you have, say, 4 stations. You could have 4 stations. In one of those channels, TDMA channels, you have, say, me going out over to somebody in the front row, Jerry responding and coming back. So you have the 2 audio signal, or the 2 setups there, plus what are the control channels? Is there also a forward and reverse control channel?
Control channel is embedded into the embedded in between the slots.
Oh, for each of the 2 QSOs, okay.
Yes. Yes. So that's the main one of the main advantages of DMR. DMR. I don't know if you're familiar with Tetra. Okay. Tetra is used in Europe. That's also TDMA. That offers 4 slots. But the disadvantage being that one of the slots is dedicated as a control slot. So in effect, in 25 kilohertz, you have 3. Well, because you can put two repeaters together, you can have within 25 kilohertz 4 independent voice paths. So it's actually more efficient than the Predator.
Okay.
Okay. All right. So the 2-slot TDMA channel revolves around a 30 millisecond slot structure. Okay. So you can say every 30 milliseconds. Within that 30 milliseconds, you have 1 slot going on. The next 30 milliseconds is for the next slot, and this alternates back and forth. So forward and reverse transmission is on a time division basis, and this allows voice, data, or generic signaling. The voice implementation that's used in DMR is actually not in the standard. Not in the standard. So what that means is that one can take the standard, implement a voice encoding method using your own voice encoding method, and just by changing the software or the firmware aboard your radio, you can have your own type of voice or data transmission based on DMR.
Does that fall under the ruling of encrypted communication?
That does not, because everything is, as long as you don't have encryption, if the encoding method is fully documented, for example, if it's open source, right, then that's not considered encrypted. Okay. All right. So again, this is on frequency bands from 30 to 1,000, which means that there's a lot more room to go for this use of this waveform. So what does that mean, half the channel bandwidth? For folks familiar with the FCC codes for FM, for conventional wideband FM is 16K F3E. Traditional analog, 25 kilohertz, channel bandwidth, 1 channel, 1 repeater, 12.5 kilohertz down, 12.5 kilohertz up. DMR, on the other hand, is 12.5 kilohertz, occupies 12.5 kilohertz channel bandwidth, 7K60 FXE, so it's 7.6 kilohertz. FXE is the FCC assigned waveform, 2 channels, 1 repeater. So DMR is more spectrum efficient than older digital modes, whereas with conventional FM, you need a guard band, possibly as large as 10 kilohertz between channels. Okay. Will allow for 22.5 kilohertz or 25. As I mentioned in DMR is designed so that you can put one next to the other and they would not interfere. So no guard band is needed. Just like you alluded to the digital TV. Digital TV, there's no guard band in digital TV. In fact, in the New York City metro area market, there is a zone where I believe 4 or 5 channels, they're all sequential, one next to each other, and you can get.
We're using the European standard, but it's just as good. Because it's easier to get that stuff, easier to get the equipment.
Okay. So there is just a visualization of having how can you get 2 repeaters in one. With conventional, you need 2 transceivers, the necessary combining equipment to get 2 frequencies, or 2 frequency pairs, to allow for a 2-channel analog system or a 2-channel digital non-TDMA system. Whereas with DMR, you have a 2-channel digital TDMA system. You need 1 repeater box. Within that 1 frequency pair, you can have AB, AB, AB. So you can have 2 calls per repeater and channel. So lower infrastructure, 1 box in the rack, 2 voice data channels, form 1 repeater. So you see here, there's also, it's not being used today, but a creative use of DMR would be for if you're really constrained on frequency, and if you can't have a frequency pair, it is conceivable to run everything on 1 frequency, to have the input coming on 1 time slot and the output coming on the other. So that's something that's definitely considerable if you're really stuck and you only have a single frequency. Longer battery life. What does it mean to have long battery life? Well, the repeater could be operating at 100% when you have 2 QSOs going, but your subscriber unit can't. So what it does is that it operates on the time slot that it's assigned to. So it's either time slot A or time slot B. So because it's not transmitting in the other time slot, it's using considerably less current on your radio. So it says here, for each hour of usage, the TDMA radio show between 19 and 34% less battery capacity than is required for conventional FDMA models. That yields 40% talk improvement in talk time in comparison with analog radios. So for a handheld, for the same battery, you can have much longer battery life. Or if manufacturers want to manufacture a nice and compact radio, they can go to smaller form factors. Okay. Or more importantly, if you have a mobile radio, it's much easier to put in a car. Being that vehicles right now have fusing arrangements, have arrangements that limit the use of whether it's a cigarette lighter or direct plug-in, because
Auxiliary power outlet.
yes, auxiliary
Auxiliary
power outlet. If you see in the newer cars, they really limit the current use. If you can't use your conventional FM radio, you maybe want to give this a try, because this will draw less than about half the current when you're transmitting. So when you're transmitting 25 watts, it's like you're transmitting 10. When you're transmitting 50 watts, like you're transmitting 25. It can be very, very helpful. It saves the battery and also allows the use of your mobile equipment. Better signal quality. So from a question that was asked, so what does that mean, better signal quality? Right? If you look at the end here, right, this is the perceived quality of analog compared to digital. If you notice that at the tippy top, at the strongest signal quality, like your S9 plus 10, S9 plus 20, analog does sound better than digital. There's no argument there. But when you step down to, let's say, S9 plus 5 or S9, right, the quality of digital pretty much stays until you get down to, let's say, S2, S3, then it starts dropping very, very quickly. What that means, what does it mean when you drop very, very, very quickly? You start having dropouts. You start missing syllables. Okay? You start having that so-called R2D2 effect. But the advantage being is that if you have, let's say, from S4 to S9, S4 to S9, you hear no difference. Right? Very helpful if you have a handheld and you're walking around. You may have variations, but the forward error correction, CRC coding, will be able to recover. So what that yields is what's called something called a processing gain. Processing gain, it's just like if your transmitter was more powerful or your receiver was more sensitive. This is what the digital will buy you. So a lot of times you hear about minus dBm, and other folks are familiar with the S scale. What I had explained was, so with analog, S9 plus 10, S9 plus 20, you're not going to get any argument from me. Analog does sound better. But once you get down to, let's say, the S9 level, and let's say S4 to S9, digital will sound like S9, whereas you'll start hearing the artifacts from analog. More noise, the noise source starts getting progressively worse. And of course, when you're at the S1 level, yeah, analog will start to shine, but then you're going to need that DSP in your head to interpret and try to read that signal. So this is where digital buys you.
So where does it drop out at the low end?
It depends.
Go by your retro.
Okay. For VHF, my experience has been that the dropout, you'll start getting the R2D2 effect at around between S3 and S4 level, right, for VHF. Right. For UHF, because of the substantially lower noise floor, I've heard people clear and without any dropouts at the S1 level.
Yeah, with analog, I mean, you go down that low easily.
Right, but you really got to strain, you really got
So
to...
you get the same kind of, you get processing gain, which actually, similar to DMR, you get you lose the low end coverage.
Yes.
Distant coverage with this.
Absolutely. At the high end and low end, you're not going to hear any arguments from me, right? And the analog is superior. But in this big zone, right, is when most people work with repeaters, that's where the DMR shines. If you do, let's say, a simplex through tropospheric ducting, that's where and the analog still has the edge. Now, that's not to say that people haven't tried using simplex over ducting, but this is where the single sideband and AM still shine.
Are we currently putting out DMR repeaters and interfacing between HDs?
I got a slide for that.
Okay.
Yeah, okay. So, better audio quality. When I have the demo going, you'll basically hear how much clearer it is that everybody sounds like they're S9. And you'll hear people dropping out, but they're usually at the edge of coverage. So listen for yourself. It does sound better than old digital technologies. Also, compared with other digital voice technologies, this has a newer, more robust voice encoding system, so that also extracts that little bit of processing data. So better for performance. What does it mean by better performance? For DMR, for radios to be called DMR, for the radios to be DMR compliant, to comply with the standard, DMR standard also requires in their units to have better sensitivity, better selectivity, better intermodulation rejection, better spurious rejection, better RF blocking, okay, better adjacent channel power, better adjacent transient channel power. What that means is that if you pick up a sub 200 DMR radio and you pick up a sub 200 analog only radio, you'll hear the difference. Whereas your conventional analog radio will be silent, the DMR radio operating in analog mode, you'll get quieting. Not full quieting, but partial quieting. So because of the superior RF front end, right, you end up with a better radio, which is what the DMR standard requires. So even if you use your DMR radio as only as an analog, you basically have a superior performing radio. So what is the downside, you'll ask? Well, DMR radios are single band. Okay. As folks may be aware, dual band, triple band, multi-band radios are a design compromise. They're compromised to the point where they still perform adequately. But because of DMR's requirements, it precludes, at least today, that ability. So another advantage of the DMR radio is that they're typically more rugged. Because they're commercial use, they're typically more rugged. They have IP ratings of IP54, IP65, and IP67. The radios that are boarded here, with the exception of the mobile, just a handheld, they're rated IP54 or IP65. What that means that they're dust tight and they're immune to splash. So if you take your handheld out to a rainstorm, as long as you don't drop it in a puddle, it'll survive just very nicely. And if you have a more robust radios, plenty of models that are IP67, what that means is that you can dunk them in water. As long as you take it out within, I think, 30 minutes, it'll be good. So, amateur digital voice systems. These are the different types of voice systems currently used for amateur use. One is D-Star. D-Star is manufactured by ICOM. They use what's called a GMSK coding and use an AMBI vocoder, first generation AMBI vocoder. P25 Phase 1, that's also multi-vendor. P25 is a US developed digital voice mode. They use FDMA, they use what's called an IMBE vocoder. Interesting about IMBE vocoder is that I believe the IMBE vocoder patent runs out, if not already, will run out by the end of the year, which means that anyone or any vendor can start making IMBE products and not have to pay royalty. Next one is System Fusion. System Fusion is manufactured by a company called Yaesu. Right? They're also FDMA. They use a C4FM waveform and they use an AMBI +2 vocoder. AMBI +2 is the second generation of the AMBI. It's a improved version of the AMBI vocoder. It's also used in DMR. DMR is also multi-vendor. 2-slot TDMA, and it's also a C4FM waveform. As I mentioned, the digital voice system of DMR is actually outside the DMR standard. So it is conceivable, it is possible for anyone to develop a digital voice, to implement the digital voice system using the DMR radio waveform structure. So what is the advantage of DMR? DMR, instead of running 2 voice channels, you can run a voice channel and a data channel simultaneously. So while you're walking around, you can be transmitting your GPS location. So it's conceivable if you were to set up your own repeater that while your vehicle's moving around, while you're transmitting your voice, the other slot's dedicated to sending your GPS location. Okay, so it's used in commercial systems for fleet tracking, okay, and fleet management. So you give your location while you talk. No interruptions. This is now, this slide is specific to the Motorola implementation of DMR, which is called Moto Turbo. Motorola has an implementation called dynamic mixed mode. Right? What dynamic mixed mode allows is that as long as you have a standalone repeater system, you can support your legacy analog and the DMR TDMA. So the repeater will listen. If it hears analog, it will pass analog, okay, and it'll preempt TDMA. If it hears TDMA, it'll pass TDMA and will suppress analog. So this is an option for phase migration from analog to network DMR repeaters. One disadvantage of the dynamic mixed mode is that it only allows for standalone operation. It does not allow for network operation. One of the nice things about DMR is that it allows networking. What does networking mean? You can connect the repeaters together. You can connect the repeaters together so that you can have a region of coverage, region of repeaters covering an area. Okay? You have region A, region B, region C. With a master, you assign one repeater as a master, and then you can assign up to 15 other repeaters to act as repeater peers. Okay? So one master, 15 peers. So how do you bridge the masters together? You get what's called bridging hardware. Bridging hardware is a Motorola partner. They manufacture bridging hardware that allows the masters to connect to each other. So if you have a peer and it's one remote node, you can go through the bridging repeater to talk to someone on another network, another peer. Yes?
Theoretically speaking, it seems to me, tell me if I'm wrong, under this bridging system, I could take a DMR handheld and literally, on this system, talk to somebody in California.
Yes.
With regards to the master repeaters.
Yes. You can talk to somebody in California. You can talk to somebody wherever you can make the IP connection, which means you can talk to somebody in Malaysia, you can talk to somebody in Hong Kong, you can talk to somebody in Australia, you can talk to somebody in New Zealand. In fact, that's happening today, as we speak. So IP Site Connect allows for either one slot, so you can dedicate one slot for talking outside your repeater, and keep the other slot dedicated just for local traffic. Or you can connect both slots, so you can have maximum flexibility. You can link statewide and region-wide systems. So what is IP Site Connect? Again, this slide is Motorola specific. Okay? A peer can participate with one or both time slots. The peer registers with the master. Master keeps the peers informed about other peers. Master and peers function as fully meshed networks for voice and data traffic. If the master fails, the mesh network continues to operate, but new peers cannot join, nor are changes announced. Okay. And a third-party bridge made by a Motorola partner is used to interconnect IP Site Connect network. So what does that mean? So repeaters can connect to repeaters, but the repeater-to-repeater connectivity is currently not in the DMR specification. DMR repeater manufacturers, they are free to implement their own connectivity. So today, Motorola repeaters can connect with only other Motorola repeaters. Other manufacturers like Hytera can only connect to their own repeaters. Currently, because of the need of the wide area connectivity and the need and the desire for multi-vendor solutions, the DMR Association is working on getting a rudimentary repeater-to-repeater connectivity set up so that manufacturer A repeaters can connect to manufacturer B repeaters. But today, that's not available. So what that means is that you can mix and match radios. So you can have in your repeater. If you buy a Motorola DMR repeater, you can use any manufacturer DMR subscriber units. But when you connect the repeaters and repeaters together, they have to be the same name. Okay, at least today. So one of the bridging equipment is called the C-Bridge. It's manufactured by Rayfield Communications. It links master repeaters and the bridges, and it provides arbitration. So what does arbitration mean? If two users key up simultaneously across the bridge, one will get denied and immediately notified to prevent dual transmission. So how does that happen? On the DMR radio, right, if you key up and the time slot is occupied, right, you'll get a call reject tone. So folks who've used Nextel before, in Nextel, when you push to talk and you hear a chirp, that means you're cleared to talk. Right? In that period of time, your subscriber units communicated with the repeater and it's established communications. So once you hear that chirp, you can talk. But if you hear a bonk or a boop, right, what that means is it didn't establish communications, whether it's because there's no repeater detected or there's somebody already using the channel. That's what the DMR offers. So if two users key up simultaneously, only one will be allowed to use it, and the other user will be rejected. Right? So the possibility of one getting on top of each other is reduced greatly. So this picture of a C-Bridge basically goes into a rack. Right? You got your IP connection, and you have this could also interface analog repeaters. So basically, you're bridging repeaters together. One of the DMR features, now this is back to the DMR standard, is text messaging. We use text messaging on our phones. We use text messaging on our radios. So what text messaging allows is that you can send text from one person, one-to-one, or you can send from one to a group of people. So if you, as a club, set up a DMR repeater, you can text each other or have one text your entire group, whether it's weather alerts, club meetings, or announcements. Just like with your cell phone, but you can do it with your radios. The OMARC. OMARC is a repeater network set up by radio amateurs, spanning by now a lot more than 1,500 sites in 45 U.S. states and 46 countries. Right? Currently, Alaska, the Dakotas, Delaware, and Louisiana does not have them yet. But every other state has at least one. OMARC repeater is also known for bridging to other Motorola repeater-based networks. It's 100% pure digital, which means that to join this network, the repeater owners have to pledge not to bridge any other traffic, like analog or the other digital modes. Currently, when I did this slide, there are 20,000 plus registered user IDs. I believe today they just crossed 23,000. And I have a website if you want to register a ID so you can buy a radio and get on the air. I understand that process is now automated, so it used to be that you have to send them the email, and then they have a web form that you apply for. Now I believe you complete the web form, you get it all.
I just did it the other day, it was instantaneous.
Yeah, it's just like, it's just as easy as buying a cell phone, they activate for you right there. There's another network called the DMR Plus network. DMR Plus network is considerably smaller than the DMR Mark network. They use another manufacturer repeater called Hytera. They're based on other Hytera repeater-based DMR networks. There's also Pure Digital. They have a interface that allows using a Raspberry Pi and an app to connect to Motorola repeaters. They are very clear in stating that you can connect to other Motorola repeaters, but that time slot cannot be shared with DMR Mark, which is sounds like a political boundary, but it is possible to have one repeater, one connected to the Motorola network and the other connected to the one slot connected to the Hytera network. Hytera network also allows a data dongle. I understand data dongles are very popular with D-Star. The DMR Plus network will welcome data dongles. It connects 270 sites in 11 U.S. states, Panama, Ukraine, mostly Europe and Eastern Europe. They share the user and repeater registration with DMR Mark. So once you've registered with DMR Mark, you can also use your radio with the Hytera Plus system. And this is the website to register or learn more about their network. This is the map of the DMR Mark worldwide repeater network. You see it's U.S. and Canada. It's pretty much full. You got the Dominican Republic here. You got Venezuela. You got Mexico. You got Hawaii. You got a bunch in Australia and New Zealand. You got that one in Malaysia. You got that one in Hong Kong. You can see most of northern, southern, western Europe covered. Yeah, and you got your nodes in 3 nodes in South Africa. So you got your 3 nodes in South America. So it's still growing. But you see it's already covered a lot of area. So within New York City, there are repeaters that belong to the DMR Mark network. One regional network is called NJ Turbo. NJ Turbo has repeaters in the New York, New Jersey, Eastern Pennsylvania area. They're also linked regionally to regional networks in Florida, Michigan, Connecticut, and elsewhere. In addition to supporting North America and worldwide networks for North American and worldwide connectivity. Another regional network is Bronx Turbo. They connect Western Long Island, 5 boroughs, Lower Hudson Valley, Manhattan, and Daytona Beach. In the Atlantic City area, there's a repeater that belongs to the MIT network. They're connected to a regional network based in Massachusetts. And Eastern Long Island repeaters and New England repeaters belong to the New England Digital Communication Network. Plus Network, they have a node in Brooklyn and in Carmel, New York. Okay. So this is the map of the New York City Metro Regional Network. So if you see the one that's here, there's one in Howell. So you have both coverage in this area. The repeater listing on the NTJPI, the NJ Turbo regional network. This list is continuously being updated, so this list I've only seen get bigger, not smaller. This is all. The next few slides will show the typical screen shots of the CPS or the customer programming software. Most of the radios, most of the DMR handhelds and mobiles, they have to be programmed using software and the PC. But there are a couple of manufacturers that are putting in keyboard programming functionality. This is what the Motorola looks like. Connect Systems also, Connect Systems is very popular with the amateurs because of the lower cost compared to Motorola's. And TYT and Connect Systems first generation CPS. TYT made their splash in the United States this year. They have a DMR radio, which I have for display here. That's less than $200 and gets you on DMR. This is a XPR 4550, which is a Motorola mobile radio. Comes with a fancy mic that allows for keyboard use so that when you're driving, you can keep your hand on the road, so you don't put your head down and look at the console. Right. The cost of the microphone is about the cost of one of these cameras. This Hypera, this is probably the #2 most popular DMR manufacturer after Motorola. This one, their MD780 models. Two pictures of repeaters, handhelds, and mobile. So Motorola XPR 7550. If you ever visit the large hotels, like the Hilton Hotel Network, you'll see a lot of their staff carrying these. You'll also see a lot of building maintenance staff in resorts and amusement parks. They have these. You'll also see these. These are the XL 7550. These are digital only. And if you notice that they look like cell phones. Because of the DMR longer battery life, they can put in smaller batteries and have slim sized units that last for a shift for hospitality. Hypera PD782, also a portable. This is a typical repeater. This is the Motorola MTR 3000, it's a 100 watt repeater. This does analog and also does DMR digital. This is a smaller repeater. Most of the DMR networks use these. They're smaller, the 50 watt, XPR 8400.
What's those repeaters
The XPR 8400, I believe the commercial price is a little over $2,000. The cost to it's called hand-friendly dealers, I believe is under $2,000. I believe it's around the $1,700, $1,800 range. Okay. But if you think about it, it's like having two repeaters in one. So for $900, it's not too bad. Okay.
What's the hundred watt?
I'm sorry?
What does the 100 watt?
This I believe costs considerably more. I think it's close to the cost of the lot.
Just so the club needs.
Does the club have a MPR?
We have a Fusion test set,
Oh, okay.
so we have the Fusion system.
Okay. But I believe MPRs are available in the used market. If you get a MTR 3000, all that stands between using this on DMR, I believe, is a software entitlement to turn that feature on. So this is a show of one of the computer sites. You've got the duplexers here. You've got two computers. I believe one's a UHF and one's a VHF. This is what a typical site looks like. You got your rack, you got your transmitting equipment, you got your UPS, and your two computers. This is also a DMR compliant computer made by a company called Tate. Tate is very big in Europe. Tate is a company that's based in New Zealand. They also make subscriber units as well as repeaters. I believe they support P25 and DMR. I believe not simultaneously, but the difference is that they use the same hardware. They just load different software. So it's a matter of time before they will allow both these or multiple digital nodes to coexist in one radio. This is Hytera, this again is the number 2 manufacturer or volume shipper of radios after Motorola. They make a 2U high, 50 watt repeater. You can operate either standalone or you can connect to other Hytera repeaters. The cost of this, I believe, is a little bit lower than that of comparable Motorola units. Comparable meaning it's about 10 to 20% more. But again, the disadvantage is you can't connect to the Motorola network, you can't connect to the Hytera network. But the advantage being that the smaller networks are quieter and the regional networks are quieter, so you can have more local traffic, more regional traffic. Here's a list of ham-friendly dealers. I have no affiliation with the first or second one. I'm affiliated with this one because this is my XYF. You can also get radios on Amazon.
Should we be proud or say condolences?
Well, the way I see it is, I got her to run the business so that I could be justified in getting new models to test them back. And you also get your radios on Amazon and eBay. These two folks are generally, if you want to buy Motorola radios or Hytera radios, since you can only get those radios from an authorized dealer. And this, we're actually the authorized reseller of the Connect system. Frequency area, well, the coverage for this area, there is a repeater in Powell that services this area. So when we get to the demo, you'll see that. Now, even inside, you'll have full signal, you have full signal coverage, so you can use your HT. Oh, that repeater, I believe that uses the 8400, which is like a 25, 50 watt. I believe in Jackson, they're trying to get a site up in Jackson. The next site from here is one in Fairless Hill. That one's on, I believe, a 450-foot tower, so that has coverage into the Philly area. And there are a number of repeaters you saw in the map in the New York City area. So New York City has pretty much full handheld coverage. So you see here, the amateur DMR growth by number of repeaters. You see it's grown past 400, but that's September 2013. We've gone way past that. We're in the 1,500, we're approaching 2,000. And growth by radio IDs, and as I reported, as of last night, they broke 23,000 subscribers. So just in the United States alone, we're crossing that 10,000 subscribers. So in the U.S., getting to 10,000 subscribers. And this was September 2013. Was that 4,000? That used to be global. So you see the growth. One example is in California. They have over 1,000 subscribers. In the state of Connecticut, they've grown very quickly because the Connecticut state areas, through courtesy of the Connecticut State Police, who are very big boosters of their area system, they made their Connecticut State Police radio sites at their barracks available to any local amateur repeater club that would like to donate a repeater. They will supply their conditioned power, their tower, their antenna, and their protected utilities for area's use. And the advantage is they also have a fully meshed microwave system, so that in a emergency situation, they cut themselves off of the broader world, off the internet, and have their own grid of DMR for their area's use. Right, so they themselves have something like 30 repeaters statewide, so in most of Connecticut you have handheld. Some DMR websites, DMR.mark-net is where you get rate general information. That's also where you register, get registration, put it in the radio. There's a Yahoo group for Motor Turbo. There's a NPJCAG, that's the regional website for the regional digital network. Another regional digital network into NSA.net and turbo.org. This is the another EMR, it's a Motorola club for the Motorola repeater network that's now integrated into the EMR. So, in summary, EMR is a spectrum efficient system. It's supported by multiple manufacturers, so you can choose the one that best suits you. Longer battery life compared to other modes. It's a resilient network. Right? There's no internet needed. Right? And if you want to learn more, you can go to this website. If you have any questions, I'd be happy to answer them. Or you can go there to start registering your EMR ID or to register for your next EMR.
Is there a consensus to moving toward